All right, so we're going to look at a couple linear system word problems. These are the two kind of introductory types of word problems that we'll look at. The first one here is a kind of format that fits with the y equals mx plus b layout, and the equations will generally look like y equals mx plus b right off the bat. So in our case here, we have a gaming platform that offers two subscription plans. The first is the basic plan that costs $10 a month plus $2 for every game downloaded. Ultimate plan costs $30 per month with unlimited game downloads. And we want to know how many games the user needs to download for the two plans to be the same cost. So we're comparing cost. So we're looking at a variable of C being cost. And then the other thing that we see happening here is that while there's a monthly fee, we're only looking at something changing based on the game downloads. So every month it may be $10 or $30, but the number of game downloads is what's changing per month. So our game downloads would be our second variable, monthly game downloads. So these being our two variables, we can create our two equations. And so in this case here, the cost is going to equal the monthly cost plus the game downloads cost. So for the first equation, and this is for our basic plan, the basic plan is $10 a month plus $2 for every game downloaded. So the cost equals $10 plus $2 per game, or 2G. In the second case, what we're looking at is the ultimate plan that costs $30 per month and has unlimited game downloads, so we're not adding anything on in terms of the number of games. So these are our two equations. So here in the first one, we have our y equals mx, notice it's at the end, plus our b. And then in the second one, our m is 0, but we do have our plus b of 30. So we can use these two to solve them. I'm going to use substitution to solve this one. You may have a plus g on the second one, depending on your situation. And so be aware of that, but you'll just sub that in where we're looking at the same cost. So C needs to be the same as C. And so if these two are the same, that must mean these two will be the same. And so we can label these as 1 and 2, and we can sub 2 into 1. And we would get, instead of this C here, 30. So 30 equals 10 plus 2G. And then we solve this for G. So we'll take that and we'll move the 10 over. We'll have 30 minus 10 equals 2G. 30 minus 10 is 20 equals 2G. And then to get rid of the 2 beside the G, since we're multiplying, we'll divide both sides by that. 20 divided by 2 equals G, or simply 10 equals G. So here we have 10 for G. And now in this case here, it's asking for how many games would a user need to download for the two plans to be the same. Well, 10 games is our answer. So we found it. We could also find the cost, but in this case we don't need it. So our answer is right here. We'd have our therefore user needs to download 10 games. So this again is kind of fitting around the y equals mx plus b, where we have a cost or a static item, or an item being related to something static plus some variable value. One or another case may not be there. In the second situation here, what we have is that a snack stand is selling chips for $1.50 per bag and drinks for $2.50 each. During an event they sold a total of 150 items and made $240. How many bags of chips and drinks were sold is what we're trying to find. So these are the two values that we're looking for. How many bags of chips and drinks? So these are the two separate items. So these will be our two variables now. So we're not looking for the overall cost because we're given that. We're also given the total number of items sold, but we need to know how many of each item was sold. So we're going to look for the number of bags of chips. So B will be our number of bags of chips. And D can be our number of drinks. So in each case, we're dissecting this down to what are we looking for. And these are the two items we're looking for, B and D. They become our variables. Now, if we want to relate them, the number of bags of chips and the number of drinks total up to the 150 items. The number of bags plus the number of drinks would be 150 items sold total. So B plus D equals 150. And this can be our equation 1. Our equation 2 needs to then relate to this total amount we made, which is 240. Well, it's 150 per bag, so 150, or sorry, not 150, but $1.50. $1.50 or 1.5B. Feel free to put 1.50 if that makes you feel more comfortable in understanding this question. But 1.5B plus $2.50 per drink, or 2.5D equals, and in this case we have 240. And notice I don't write the dollar sign down. We don't want to include the units like dollars or inches or anything like that in here. We're just leaving the numbers by themselves to not add extra pieces that may be confusing. So in this case here, I'm going to solve it with elimination. Substitution works just fine, but just for an example of elimination, we're going to use that. So what I'm going to do is I'm going to get rid of the B value. And to get rid of the B value, I need to multiply this one by 1.5. So I'm going to multiply the whole top, so B, D, and 150 by 1.5. And what I'll get here is 1.5B plus 1.5D equals, and 150 times 1.5 is 225. So I have all my values here. The bottom one, since I already have it as 1.5B, I don't need to multiply it. Again, this is similar to like getting a common denominator between two values. So I have 1.5B plus the 2.5D that's already there and the 240. So here I have my values. Now, if I want to get rid of the B, 1.5 minus 1.5 will be the 0. I don't have to add this time, I'm going to subtract. 1.5 minus 1.5 is 0. I'm not going to write that down. 1.5 minus 2.5 is going to leave 1D, or just D. And it's going to be negative. So a negative D value there. 1.5 minus 2.5 is going to be negative D, or negative 1D. Again, write the 1 if that makes more sense to you. And then we're subtracting 225 minus 240. So the difference here is going to be negative 15. So I get a value of negative 15. In this case here, this is like negative 1D. This is like negative 15. You can do D equals negative 15 divided by negative 1. Or recognizing that both are negative, if I want positive D, I can just get D equals 15. So now I have that D equals 15. I have the number of drinks that I sell, and I can now calculate the number of chip bags by substituting this value in to one of the two equations. Ideally, I'm going to pick this one. Both will work, but B plus D equals 150 seems a lot easier to work with because there's no multiplication going to be involved. So I'm going to pick that. But if you pick this, you should get the same answer. If you don't get the same answer in both cases, then there's a mistake along the way. But we'll sub D equals 15 into equation 1. We get B plus 15 equals 150. And then we can calculate the value by moving the 15 over and subtracting. B equals 150 minus 15, or B equals 135. So we have 15 drinks and 135 bags of chips sold. So therefore, 135 bags chips and 15 drinks were sold. Again, with a question like this one, we're noticing that there's two separate variables we're working with, and so in a lot of cases when we're specifically looking for both variables, we're going to be having a sum of the variables and then a multiple of those variables along the way.